All right, this is PlayStation Repair Augusta doing another live stream. This time I have a constant blue light of death, which is a symptom and issue that plagues even the most experienced repairers because it's such a general issue. Oftentimes, this constant blue light of death is deemed not repairable just because there's really no way to find it. But every now and then you get lucky. There's a few go-to repairs. You'll hear people mention things about reballing the APU or replacing the south bridge. Um, you'll hear them talk about they kind of scanned the board and went through and probed different areas that they know to be potential causes, and from that eventually reverse out a solution. Well, I had yesterday one of the latter, and this fix may not necessarily apply to your case, but it does demonstrate a very important part about a constant blue light of death. Very often do I get a phone call or a text message, some type of communication from a concerned user of their console. I've got a constant blue light of death and I don't know what to do. I've looked on YouTube, which is a whole nother subset of dreaded things that repairers hate to hear. There's a lot of bad information out there on YouTube, and this one is usually part of them. They go, oh, it's just the battery needs to be replaced, or it's just the APU needs to be reflowed and my cousin's got a heat gun. Will that fix it? My answer is maybe. If you want to try it, go ahead. The question is, do you want your machine to 100% work afterwards, or is it okay to take the risk? And if it does go wrong, you're okay buying a new one. And like I said, with constant blue light of deaths, it's not to say that your repairer is going to be much more successful, because the bottom line is until Sony mans up and admits that their schematic, their the name is evading me at this point, there's a name for it, and my mind just went blank. It is a schematic, yes, but we call it a service manual. A true service manual, not the one that they give out with the machine where it goes, oh, this is how you turn your machine on. This is where the plug attaches. This is how you pull the plug out. No, dum-dums, we're talking about the real service manuals that you distribute for whatever you consider to be an authorized repair center, which to this date I have never ever seen one, so it appears that this manual is made strictly for internal training purposes, but eventually they do get leaked. I think the PlayStation 3 service repair manual was leaked about 3-5 years after that machine was considered end of life. So at that point it was pretty much useless. But you know, there was still a value, but in the US it was very, very little. I'm sure in some of the other countries where that work can be sourced much more cost effectively, that repair manual probably does people a lot of good and has created business for many. But getting back to the point here is that there's just basically no way of knowing exactly what is the cause of a constant blue light of death. What it actually means is it's a general fault code error, that it's telling you basically anything could be wrong with your PlayStation. So it could be, let's just point, it could be this chip, it could be this chip, it could be underneath this chip. And by the way, one of these days I will show what the underneath of this looks like. If you thought the BGA package that I showed before had a massive amount of tiny circles crammed into a square, what's underneath this one will boggle the mind, and how even the sophisticated machine that does it places these flip chips properly is, I mean, it's got to be an art form to watch. I think I've seen a video that kind of briefly showed it, but again, I digress. Let's get back on topic. This repair could be telling you, or this constant blue light of death could be telling you that any of these chips, and if we look to the bottom right corner where we see everything else that is on the board. It could be any of these chips. And if we want to go a step further, we can flip it over and it could be any of these chips are causing the problem. Now, I'm sure there's probably a few that we could rule out and say they aren't going to cause a problem. Like, let's go over here. I could guarantee you that this chip here is not going to cause a blue light of death. So there are some that we could rule out and say they're not the problem. And I'm an idiot. I had the chip that I wanted to show you placed on the board, and I flipped it like the dum-dum that I am. Again, if it's live, anything and everything will go wrong, especially when you're watching a live stream for me. Now, what the hell did I do with it? This is going to be great because I gave that a nice little twist too. We're about to flip a keyboard, make sure it didn't land there. Oh, I'm going to find it, people. I can't believe I did that, though. I should have used a little sticky tape and adhered it because I should have known that I would do something like that. But you know what? That's what makes today fun and interesting, is that I'm going to screw up constantly and you're going to get to laugh at me and make funny comments about what kind of a dumbass I am. And in fact, it was right here at my feet. So let's get our camera lined up and you will get to see exactly what caused this blue light of death. Such a big problem, such a tiny, tiny chip. So here's what we've replaced right here. Let's take a look and see if we can read these numbers off. And then I will show you what it looked like when it was on there. And I pretty much already know what this chip is. I've never actually looked it up. I'm just making a very, I would say, informed, based on where these lines are running out to, guess of what this chip's purpose is. And to be honest, I wouldn't have thought that it would have caused a blue light, but I guess in the way that it failed massively. So we're looking at 88EC060NNB2. Let's punch that in online and see if we can find anything out about it. Now, this is a Macronix chip. I believe that is the logo. We'll get verification of that as we punch this number in. So we're going to type in 88EC060. And thank you, Google, for auto-completing, because now I don't have to type the rest. And it comes up. Oh, wow, they used this chip in the PS3 as well? Maybe? You can actually find these online as replacements. I'm wondering if they're pulled or if they're new. It's probably a general chip used for plenty of things, but as I assumed, it is the Ethernet controller, which, if you follow these lines, there we go. Guess what this is? An Ethernet port. So now let's show you what the original looked like on this bad boy. And get my camera right. I did finally figure out that color filter. So we're getting a much brighter, it may be a little too shiny. I may still have to tweak it some. And when I get the new desk set up, I'm going to have a different lighting configuration, so it may even be less of an issue. But check this out. And this is the way, this makes that it lines up exactly as it would have. This is what was on this board. So very clear signs, to me at least, and if I'm wrong, somebody feel free to correct me, but my opinion is that there was a lightning strike on this board, and that bad boy went straight through these lines and had so much potential energy, it must have hit some type of a stop gate and had nowhere to go. So, and I've said this before, electricity doesn't follow the path of least resistance. It was one day explained to me that Electricity follows all paths. The majority of it may flow down the path of least resistance, but when it's traveling down a path and it's got nowhere to go, what looks like happened to me is that it decided to explode out the top of the chip. So we definitely have a damaged chip here, and guess what? When we replace this with one from another board that we knew was good, the blue light went away. We now, although not completely done, we have a white light of death. And that I've already started to take the steps to repair. There may be still a slim chance that this machine may not be repairable. I'm pretty sure that we're looking at an encoder issue, which, as you can see, I've already removed from this board. And you can't see crap in that because that is blurry. But we had full short across all pins, not just one, not just two, but all 19 pins were short to ground. Well, some of those pins weren't short to ground, they were connected to ground, so they were supposed to be. But definitely, it is a rare situation where every pin across the board on the HDMI is short. And in my experience, every single time that is the case, there's a lightning strike. Now, with this though, I've had them where I found that I've removed the shorts at least as far as I could tell, but either the machine just wouldn't boot or it would continue to blue light even after removing detectable shorts that were found. In this case, we didn't have that problem. Like I said, simple, easy peasy, replace the Ethernet controller, and we're back up from a blue light with a white light of death, but I'm expecting to have that fixed. I'm going to go through it basically till this thing falls off. If I have to, after that's done, do a reflow, reball, whatever on the APU and dig a little deeper, this goes into the part of reverse engineering what causes these faults. Because again, like I said earlier, PlayStation isn't sharing any information. If they were kind enough to distribute those documents, I could do some simple probing based off the schematics, and I could determine whether or not this board is truly tanked or if it's going to be salvageable. So I will post an update letting everyone know if this was 100% corrected. But the fact that the blue light of death, the constant blue light of death, which plagues boards where, I mean, the success rate on the constant blue light of death, I would have to say, from month to month will range from a 50% success to 80% success, and 80% is probably a lucky month. And that's just because, again, it could be some really weird random stuff. And then other times it's exactly what you think. It is the APU is just shot and something inside of it. Probably my guess would be more on the graphics end rather than on the actual processing end, because I would think then that it would probably fail to boot and wouldn't stay constant. However, again, this is just speculation until we get some type of documentation from Sony so that we could do some more intelligent probes. But until then, we use kind of a reverse engineering method. And that method says, try what you know. Actually do the repair in the process for what you know. And then if that fails, probe, study, learn, probe some more, study till your brain feels like it's going to melt. And then eventually you start to put these pieces together. You start to figure out what's going on in all the parts surrounding the controller. You eventually get to the point where you're pulling your south bridge off and your contact probe looking for connections between components that are located and involved with this Ethernet controller that may join up and sync back with your south bridge. And if you get to the extreme where you're pulling out a board that you've already just stripped everything off of and you're really trying to figure out what is going on, you're looking for commonality points between major chips that are involved in that boot sequence to see if they could have potentially been affected by where the known shorts were, or just in general those problematic components that you were able to isolate. So Not sure if this paints an accurate picture, but there's been some simple repairs, like on an Xbox One, where it was simply just no power to a disc player. And it was literally 10 hours of diagnostic research to figure out the components involved and what it took in fixing that to get power back to the Blu-ray player so that it could pull in and spit back out disc. But other than that, there's really not much more to show on this video. I think that sums it up, is that I wanted people to understand that constant blue lighted deaths can be really anything. However, your very first weapon in the fight against a constant BLOD is going to be your eyes. You want to scan this board everywhere. You're looking for chips that look damaged. I mean, basically that just look off. And sometimes the damage is not that obvious. Other times it will be, something teeny tiny. It could be something just this small, and you have to get that microscope deep down in there, and you're moving the board like this to scan each of those little parts until your eyes see something suspect, and you may see what just looks like a hairline fracture, because when a component's this small, it can't do this big footprint of damage. So it becomes a little bit harder to tell. So you got to really just kind of take your time and look it over. And if nothing's obvious, then you start looking at your known solutions. Repairs that you've encountered in the past that have gotten you to the result that you want to get to. You investigate those and see, is there a commonality? And if there is, pursue those commonalities until you either disprove them or find a way to get to your solution. And I've had boards where, especially I had one board not long ago where a customer decided they wanted to repair it. And I'm all for DIY. It's why this channel has been created. There are certain things that you can take care of yourself. And this customer really didn't do anything wrong, except for once they decided that they couldn't get the machine fixed, they didn't immediately take it to somebody to treat it. It kind of set off to the side in pieces, and eventually a bunch of stuff got knocked off. So it was brought in for an HDMI issue and fixed the HDMI and then booted up, and guess what? Well, actually I couldn't boot it up at first. It wouldn't detect that button press. Well, turns out there was a component knocked off from there. So replace that component, and again, this is where this stuff is small. Even I'm missing it because I wasn't looking for it. Once I said, okay, something's not right, I went to look for it, and I get the power button back going, and now it turns on. Get everything up, it says, oh, you need to reinstall firmware. And I go to put in the controllers and a USB stick with the firmware, and it can't detect them. So after thinking, and again, my mind not being on the fact that a component's already been knocked off, I should have been looking for more, I went to do firmware. I went to do replacing the Blu-ray chip. And all of that failed, and I'm like, what is going on here? And then finally the aha moment clicks is, wait a minute, we got a component knocked off before. Let's check and see if there's another component potentially knocked off. And sure enough, flip over the board to the USB side, and I say flip over because I'm looking at it in its orientation now, and there was not just one but 3 components knocked off from the USB side. So we get through that, and now I put it back together, and I can now do a sync. I can get a USB, I can do the update. The update goes all the way through to the end, and guess what? It fails. Why does it fail? It fails because the Blu-ray player isn't working. Well, why is the Blu-ray player not working? Would it be the same issue we just had on everything else? Yeah, it was. More components that were knocked off. Now in this particular case, I think actually there was one component that was truly knocked off, but not a component that would have done some big harm. But there was another component which had been partially knocked off to the point where it was damaged, but you couldn't really see it. Even on the microscope, it was hard to tell until I really started kind of like prodding at it, and it gave way, and it made the fissure of a crack in it basically just crumble and break apart. But long story short, that particular component, I guess when we had fixed everything else, at that point was then able to send a bit of a surge of electricity through, and that's the only thing that I could imagine. Or it may have happened in the very beginning, and it just, again, wasn't known because we could never get to that point. But to this date, that Blu-ray player has not been able to come online, and I have not done um, the final two steps because at this point I've spent so much time, energy, and resources on it that it's really not worth pursuing anymore. Um, it's past the point of just replace it and move on. But I'm kind of curious to know, and the only things left to do are to swap the Bluetooth or the Blu-ray, not the Bluetooth, the Blu-ray controller chip over to a different board and see if it is truly the issue or if there is something else potentially going on wrong. And this is a machine with a daughter board, so I say that daughter board may have a problem, but I think that it's either the the Blu-ray player controller IC is damaged and defective due to some type of overvoltage, or the the board, the main board, still has some undiscovered issue that is preventing it from moving forward. But ever since update 5.0, it may have been slightly before that, but I know at least from update 5.0 or 5.01 that if your Blu-ray is in any way malfunctioning, your updates will halt. Your machine is now a brick. You will not pass that point ever again. And that is where this machine is at. So the moral of that story there is that you need to check your board in its entirety because you never know where these problems are going to come from. You got to pay attention to every detail, and don't do like me when the problem arises. Go, oh, just my go-to fixes, which we tend to kind of get stuck in our ways. It's human nature, but be observant. Look around the solution. Think of the problem as a whole. You don't always have to think outside of the box, but you do have to always think about the entirety of the box and not just inside of it. So once you kind of get familiar with the components on the board, their voltages, their readings, it's kind of like getting to know a family member. You got to know their intricacies, and then you can kind of predict what they're going to do. Once you get that level of familiarization, you'll do much better with this. And if you're just a user, you don't plan on doing repairs over and over and over again, do I discourage people from repairing their own? No, I don't. If you want to, go for it. I encourage you, take what you've learned or what you can learn and have fun. But realize that there is a risk, and if you take that risk, they'll be mad at me if you end up not coming to a solution, and pursuing a solution ended up making the problem worse than it was. So that's where you don't win every single time, but if you take your time and you go through every single step, you can often be successful. But do expect if it's your first time going through something, you probably want to allocate about 4 hours to kind of playing around, poking and prodding. And if you're going to actually be soldering something, it may take you even longer because you got to get comfortable with a soldering iron before you get to be able to do some of these micro level soldering. So have fun. Take this lesson for what it's worth. If you are another repair shop out there, this will be a great kind of video just for showing you, what is a potential issue with a constant blue light of death. And I kind of got off on a rant there and lost my place a little bit, but overall, the moral of this story is, like I said, is inspect your board. Look at every component. Don't doubt that anything could cause your issue when it is a blue light of death. If your thinking is that only the APU could be the problem and you're going to reball it and save the day, you're probably going to spend most of your time wasting your time, because this as a fix for a blue light of death, or a constant blue light of death, I should say, is probably only, I don't even know if I'd call it 50%. I'd have to look back through tickets, but yeah, don't hang your hat on the APU, and I'm not sure if it gets a little too dark back there, but there you go. There's the back end of the tweezers, which are a little wider. Don't hang your hat on the APU being the issue, because it could really be anything. And the one thing that you hope it's not is a firmware issue, because, ladies and gentlemen, there is currently no fixing that unless you already have a backup. I've looked at starting to do backups of these as a kind of a just a general do it for everyone on every repair, but it's a little bit more cumbersome and it just adds to the overall cost. But if we start getting to where we're working in this area, pulling this and sticking it into an adapter, like for this one I have the adapter, it's not a big deal, but I am a cheap, frugal person, and the adapter for the next series of boards where these are, what are they called, QFNs, NQFNs? I forget the acronym, but it basically means that it's leadless, which means it's direct solder, so it's a flat pack underneath, doesn't have the legs, and the adapter that works for that model is like 75 bucks, and I've just been cheap because it's not an often enough necessity, and I just tap a soldering wire to it. But if I was going to do this for every customer, then I would need to make that investment. But having a backup of this would save you from that firmware issue, and it does happen. Samsung, or sorry, not Samsung, Sony denies the crap out of it. But I've got a board for my own personal use that one day just tanked on me, and it happened right after the 5.01 update over the Wi-Fi, which plenty of people have said Wi-Fi is not always the most stable, so maybe Sony can blame it on an intermittent Wi-Fi, but I still blame Sony that why is your update so easily broken? It should have some type of tolerance. If that requires a dual chip with a backup so that it has a way to recover, then that's what you need to do. But there should be no reason why firmware ever causes a machine to completely go bust. It's unacceptable. So having a backup of this will save you in, I would probably say, less than 5% of the situation. So again, that's where I look at it as cost to benefit ratio. It's not a big enough issue that I would say you absolutely right now need to tear your system apart and get a backup of it, but this could be a potential for your blue light of death, and definitely a constant blue light of death. You could have a ton of other potential problems that cause it, but as you've seen today, some that stand out are big ICs, where obviously they can short to some way that causes a major fault. Then you could have firmware, you could have your APU issue. RAM is a pain in the butt for constant blue light of deaths, and that is because there's just so many of them. If it was one RAM chip, we'd pop it off, put a new one on, see what happens, and be golden. But on this particular board, we've got 16, and doing that exceeds any cost that anyone would want to pay. So this is where you run into problems that they're impossible solutions. Not that you couldn't physically perform them, but cost effectively performing them in comparison to buying a new one. But if Sony would be so kind as to say, hey, you know what, we want you to get your machine fixed, and we want to make it easy for you where you can do it locally rather than having to mail it off, they could simply provide documentation that would allow technicians to probe and make informed decisions without having to do informed decisions learned through tedious hours of reverse engineering. So again, I've gone on longer in this video than I've wanted to because I've been doing this for years, and just now finally have I decided to push forward with this channel. And this is years of frustration that are coming to light as I'm making these repairs. I'm getting to voice some of these encounters and frustrations, successes. You get the good, the bad, and the ugly in these conversations because I'm highlighting my happiness for finding a solution to this one. But I'm also expressing my disdain that it has to be as complicated as it is. So again, if you like this video, if you feel that it kind of give you some light onto what could cause a constant blue light of death, better than just the videos out there that go, oh, step on your PlayStation and it'll start working again. Don't do that. That's probably the most ridiculous fix I've ever seen. But again, if you find this video useful, if you feel like it has enlightened you as to how you should approach a constant blue light of death, and hopefully made your life a little bit easier when addressing these situations in the future as a repair shop or as a console owner, and making that decision of whether or not you should attempt to get it repaired versus just go ahead and go into the store and having it replaced. Again, I hope you've learned something. If you do have any questions, feel free to comment in the section below. I will try to answer them as they come. As this channel is new, there's not a lot of questions coming in at the moment, so those answers should come pretty quickly. But if it gets busy and I don't respond immediately, don't get mad. Don't shoot the responder. I'll eventually get back to you, and if I don't, just shoot a reminder and we'll see what happens. But other than that, take care, have fun, enjoy this video and the next. There will be more to come.